Good morning, Trig. We are going to be covering lesson 60. We're going to get into some more complicated trig equations that we're going to be solving. So there's a lot of review in here, but the first thing I want to review is some basic factoring. So let's talk about factoring where I have a difference of two squares, and then factoring in an example where I am factoring out a GCF. And so just a little review before we jump in. So the first off, if I have x squared minus 1 equals 0, let me get the glare away. My factors are the square root of x squared is x, the square root of 1 is 1, a difference of two squares, one factor it has a plus sign, one has a minus sign. So those would be my factors. And then to solve, I would then set each one equal to 0, so x equals 1 and x equals, and you can write it a couple ways. You can write it together or separate, x equals 1 or x equals negative 1. In the case of a GCF, so x squared plus x equals 0. In this case, it's not a difference of two squares because I don't have two things that are squared, but I do have a greatest common factor, and that greatest common factor is x. So what would be left in the parentheses is x plus 1. And then to solve, I would set each of them equal to 0, so x equals 0 and x equals negative 1. So that is just a review of the kind of factoring we're going to be using today in order to solve trig functions. So here we go. We're going to do several so that you have a feel for how to do this. And so here we go. We are going to solve the following given that theta is greater than or equal to 0 degrees but less than 360 degrees. So we're only looking at the angles given that domain. So let's start simple. I say start simple, but then I'm nervous we're going to end up with more complicated ones. But let's start with number 1. So we're going to solve the sine squared of theta minus the sine of theta equals 0. Now a couple things to keep in mind. Remember that this doesn't mean that sine is actually, it's like there are two signs there. Like think of this as x squared, but we write the exponent in between, not on theta. So I'm going to factor. I notice that I can factor out. This has two signs, this has one. So I'm going to factor out a sine of theta, and then in parentheses, if there are two here, that's what that represents, then I have sine of theta minus sine divided by sine would just be 1. So I'm taking 1 out, and this equals 0. So I'm going to do what we did above. I'm going to set each equal to 0. So I'm going to set the sine of theta equals 0, and the sine of theta minus 1 equals 0. Now this one I can simply start solving, but this one I would have to add 1 to both sides, so I'm solving for the sine of theta equals 1. So when we're solving, we're asking ourselves what angles produce these values. So for this problem in particular, I noticed that I've got a 0 and a 1. And no special triangle is going to give me those values except for my quadrant angles. So right there's 0 degrees, 90, 180, 270, 360. So the coordinates. So remember, when I write my coordinates, it's cosine and then sine, meaning that cosine represents our x value and sine represents our y value. So when is the y value 0? Okay, so let's look at that. The coordinates here are 1, 0, and the coordinate here is negative 1, 0. So the degrees in which my y value is 0 is 0 degrees and 180 degrees. That is when the y value is 0, because that is 0 degrees, right? You're starting there, and 180. Now notice it can't be 360 because I put less than. I didn't put equal to, so I can't actually record 360. So yes, there could be, it could also be 360, but that is past our domain. So now let's talk about when does the sine of theta equal 1? Well, the coordinates up here are 0, 1. And the coordinates down here are 0, negative 1. Notice this is positive, so it's referring to this coordinate here, which is 90 degrees. So if you'd like, you can write all of them together, or you can keep them separate. But the angles we found, theta, I like to write them in numerical order: 0 degrees, 90 degrees, 180 degrees. Okay. So now, and I don't know if this helps at all. Number 2, we're going to solve the tangent squared of theta minus 1 equals 0. All right, so for this one, I notice I don't have a greatest common factor because tangent and 1 share nothing in common. But I do know that I can write this as a difference of 2 squares. So this is really tangent of theta plus 1 and the tangent of theta minus 1, because that right there is a difference of 2 squares. Now this is all set equal to 0. So now that I have my factors, I'm then going to set each of these equal to 0. So the tangent of theta minus 1 equals 0, and the tangent of theta, whoops, this is plus 1, minus 1. Right, and then I'm going to go ahead and get the tangent by itself. So I'm actually solving for the tangent of theta equals negative 1, and the tangent of theta equals positive 1. So that is what I'm solving for, right? I'm asking myself what angle gives me negative 1 over 1 and positive 1 over 1, right? This is there's an invisible 1, 1. So let's start with knowing what triangle that's from. That's from my 45, 45, 90, 1, 1, root 2. And let's also review where tangent is both positive and negative. So all students take calculus. So let's start with negative and what angle I'm talking about, right? I'm talking about the 45 degree. So I'm talking about versions or related angles of 45 degrees. So let's start with positive 1. I know that sine is positive, tangent in quadrant 1, right? Because all trig functions, this represents just tangent. So I know that theta equals 45 degrees because that would be the angle in quadrant 1. In quadrant 3, that would be 180 plus 45 degrees, which equals 225 degrees. Now, when is it negative? Tangent is negative. All students take calculus. It is negative in these two quadrants. So in this quadrant, it would be 180 minus 45, which is 135. So theta equals 135 degrees. And in quadrant 3, or quadrant 4, that would be 360, because you're almost a full circle, minus 45 degrees, which equals 315. So there is the solution there. So I'm going to write these all together. Theta equals 45 degrees, 135 degrees, 225 degrees, and 315 degrees. So those are the 4 solutions for this equation. Moving on, I'm going to do another one just in case you need it. Okay, and I'm going to take a sip of coffee while I write it down. So we are going to solve the cosine squared of theta equals 1. Coffee, too hot. Sorry. All right. So let's talk about this one. This one looks different. I don't have, I need to make sure that when I am factoring, remember the right-hand side has to equal 0. So I'm going to rewrite this to be the cosine squared of theta minus 1 equals 0. Then I'm going to factor. So cosine of theta plus 1 and the cosine theta minus 1 equals 0. Right? The next thing we do is set each equal to 0. So this would be the cosine of theta plus 1 equals 0. The cosine of theta minus 1 equals 0. And hopefully then you recognize, okay, I am now solving for when does the cosine of theta equal a negative 1 and when does the cosine of theta equal a positive 1. Okay? So let's talk about what we remember about cosine. When I see a 1, I know I'm not dealing with a special right triangle. I'm dealing with my quadrant angles. And I remember that cosine is x, sine is y. So if it helps, I like to draw as much as possible. Why? Because I miss less problems when I have pictures. So when does cosine equal negative 1? I'm looking for the x value. And that would be here, this angle right here, which is 180 degrees. When does it equal positive 1? At 0 degrees or 360. But I can't equal 360. My domain was less than 360. So in this case, theta only equals 2, 0 degrees, and 180 degrees. Make sure you're putting degree symbols on here because your answer is in degrees. All right, moving on to 60.B. 60.A was on factorable trig equations. 60.B covers that there is a loss of solutions caused by if we divide factors, if we divide instead of factoring. So this section just goes over, don't divide out common factors. Simply factor. Okay, so when we divide, things cancel. And if we cancel anything, then we're not going to be solving it completely. So don't divide, simply factor each problem. So 60.B just goes over some more complex factoring. So I'm going to jump in. We're on number 4. So again, I should give the same directions if you need them again. Make sure that we are solving. I shouldn't put solving, I should just say solve. Given that theta is greater than or equal to 0 degrees, but less than 360. So that is why earlier it didn't equal 360, because it doesn't say the equal to symbol. So number 4, we're going to solve 2 times the sine of x times the cosine of x equals the sine of x. Now, what they're saying earlier is we are not going to divide by the sign, right? Because that would make it cancel. I'm simply going to factor. So the first thing I'm going to do is rewrite this so that it equals 0. So that would be 2 sine of x cosine of x minus the sine of x equals 0. Right, I just subtracted the sine of x. Now I'm going to factor out sine. So if I factor out the sine of x, I'm left with 2 cosine of x minus 1 equals 0. Okay, hopefully you can see that. I just removed the sine out of each one. Sorry, I'm just making sure these are good notes. Now I'm going to set each one equal to 0 to solve. So when does the sine of x equal 0? When does 2 cosine x, and I'm going to raise this one up. When does 2 cosine x minus 1 equal 0? Well, this one over here is easy. This is asking when is the y value equal 0. Okay. And that would be, when is the y value? That would be here at 1, 0, and here at negative 1, 0. So x equals 0 degrees and 180 degrees. This one is different, right? I would have to add 1, and then I would have to divide by 2. So this is asking, when does the cosine of x equal 1/2? So for this one, I'm going to draw my special right triangle. I've got 1, 2, root 3. And so the answer is 60 degrees. But I have to consider when cosine is positive. So cosine is positive in these two quadrants. So in quadrant 1, that would be 60 degrees. In quadrant 4, that would be 360 minus 60 degrees, which is 300 degrees. So in this case, x equals 60 degrees and 300 degrees. So I'm going to write them together. X equals 0 degrees, 60 degrees, 180 degrees, and 300 degrees. Those are my 4 solutions. All right, we're going to do one last problem, and then that will wrap up this section, and I will go over the problems to skip on your homework. So last one, number 5. The tangent of theta times the cosine of theta equals the cosine of theta. So again, I'm not going to divide by cosine because that completely cancels that trig function. I'm simply going to get it all on one side and factor it. So I'm going to rewrite this. This is the tangent of theta, cosine of theta, minus the cosine of theta equals 0. So that's step 1. You have to set it equal to 0. Then I can factor. And I notice the GCF is cosine of theta. So cosine of theta, I'm going to factor that out, and that leaves me with the tangent of theta minus 1, don't need such big parentheses, equals 0. Now I'm going to set each of these equal to 0. So when does the cosine of theta equal 0? When does tangent theta minus 1 equal 0? So remember, cosine is x, so when does x equal 0? Well, x equals 0 here at 0, 1, and here at 0, negative 1. So x equals 0 in 2 spots. So theta equals 90 degrees and 270 degrees. This one I have to add 1. So the tangent of theta equals a positive 1 over 1. So I know that that is the 45 degrees. And all students take calculus. That would be here at 180 plus 45 degrees. So theta equals 45 degrees and 225. So I'm going to write those together. Theta equals 45 degrees, 90 degrees, 225 degrees, and 270 degrees. Hopefully those notes help. The homework for lesson 60, you are going to skip numbers 5, 21, 26, and 28 through 30. Thank you.